Hello, hello. Okay, so we are going to start with a new kind of a learning where we will be seeing dynamic programming, how dynamic programming can be useful in our competitive programming and to solve questions of DSA and algorithms. From last few months, I was just going through the learning of the dynamic programming. Now I would be more comfortable in going through the live learning. So it would be a live learning for me as well. So we will be taking the help of the ChatGPT to start the live learning, and it would be a kind of a interactive learning with the help of the ChatGPT. So ChatGPT will be helping me in the learning of the dynamic programming. So I'm just exploring how we can use ChatGPT directly to help us in a new way of learning in the modern AI world. So this is the question number one we are going to see. So I have already set up the context for the ChatGPT chat and the context is ready. So ChatGPT will be helping us in just going through the questions step by step and asking certain questions, and it would be a kind of a learning that we will be going through. So the question, so we are going to target for now the beginner level dynamic programming. In this we are going to see the unique paths question, the minimum path sum, triangle based, minimum falling path sum, unique paths. Then we have the intermediate questions, maximum path sum, dungeons game, cherry pickup slash ninja entrance, advanced. We have multi-agent grid DP and harder state design problems. So slowly we are going to move ahead and continue our learning. So in the question number one, we are going to see how what the question number one says. Let's see what is the question number one is saying. It is saying we need to have a unique paths. So we are given a matrix of m cross n, which is of m cross n size. We start at a point of the top left, so it is our starting point, and need to reach the bottom right. So bottom right is m minus 1 and n minus 1. If the m and n is the length of the column, m is the length of the row, to reach the bottom right, we would be seeing m minus 1 and n minus 1. So what is the next condition? The next condition says that we can only move to right, which is if we are on the first cell, we can move to the next cell. It means that column would be changing by plus 1. If we and we are also allowed to go down, which means that we can increase the row count by 1 and then the column. So this is the example what we are going to see. So what we need to find is how many different paths can take us from starting point to the destination. So for example, our matrix is 3 cross 3 of grid, and we need to reach the last point, which is sixth point. How we can reach that? Okay, so this is our interview setup. So we are standing at this location of the row slash column, and we are asked how we can reach the current from the current cell to the last cell. So the question says that what choices do you have from the current cell? So according to the questions, we have these two choices only. So let's try to copy this question, paste it here. Let's write the answer. We have two choices. We have two choices. First choice says that we can move to next column. So our column would be column plus 1 on the same row. Next we can move to next row, which would be like row plus 1 on the same column. So we have only two choices. If we are standing on a particular cell, we have only two choices to go from according to the question. Either we can go to the next column in the same row, or we can go to the next row on the same column. Let's try to submit this answer to the chat GPT and let's see what it says. Okay, so it says that yes, you are correct. You need to go to these two things only, the first recursive call and the next recursive call. So our recursion tree would look like this. If you are starting on the 0/0 as a starting point, either you have the option to go to the right or to go to the down. Now comes the most important part of the recursion. What should this particular recursion solve row comma call return? So our main goal is to count the number of the paths from 0 to 0/0 till we reaches the last cell. So we need to complete this sentence. Let's copy this thing. So the question is asking, so this particular algorithm or the recursion function should return from the current row to the destination. What it should return? It should return count of all possible paths to go from the current row to the destination. I hope so. This should be correct. Let's submit it and see. So it says that the number of the possible paths to the destination, exactly this is expected. This is too important because tell us to how to combine our two choices. So now the next question is, if the right tell us this and this. Question number 3, we need to consider these two situations. So case A says that we go outside the grid and we successfully reach the path. So these are the two base level conditions that will help us in controlling the recursion. Okay, that will help us in controlling the recursion. So the question of the part A, if we go outside the grid, if we go outside the grid, let's say that if I go outside the grid, so that is not my valid path. Technically, that is not my valid path. We should return 0 for that. Okay, if it is not the valid path, we should return 0. That is my count. Now the question number B, with the case B says that if we successfully reach the last destination, what it should return. So let's say that if we reach the last destination, we should return one count so that we would be able to count that path. Let's submit this answer and see how it goes. So it says that exactly right. So our assumption is correct. The reasoning is more important than memorizing the values. Always don't try to memorize the thing. So if you are moving outside the grid, technically that is the invalid path. And if your destination is reached, that is the one valid path and you need to count that path. So that is why we return 1 to count that path. So now we know the reasoning is more important than memorizing the values. So these are the two recursive functions that we would be using. Now the question number 4 is recurrence. Suppose you are on this cell, it is the question, meaning going right gives the 3 valid paths and going down gives the 2 valid paths. What should solve row comma call return, and based on that what should our recurrence be? So what it should return? It should return, according to me, the sum of the right possibilities and the down possibilities. It should return the sum of the right possibilities and the down, which says that down possibilities or the down valid paths. So if we submit this thing, so that is our exactly the expectation. So till this point, we have derived the entire recursion with ourselves, and the question number 5 says that write the recursion. Now take these m and m slash m cross n as these two values and write the complete recursive solution. So let's try to write it down with the help of our all the algorithm that we have studied, and just we try to use that. So we will take a 2 minutes break and then we start it. So let's try to open our VS Code. I was just setting the VS Code. So this is my VS Code setup, and this is my main.py file. So let's clear up our terminal and we are going to write the code here ourselves. If we come to the question, so this is our question. It is asking, we take these two values, we take these two values, m and n, and we need to define a function which solves the algorithm that we have studied just now. Okay, so this is our ask. So let's start by solving our designing our algorithm. If we see, if we see our just we scroll above, this is our algorithm that is we need to have it. So let's open our VS Code. This is our VS Code. We need to have a base case if our index goes out of grid. That is our base case number 1. We have another base case number 2. If our index reaches destination. So what is the coordinate of destination? M minus 1, comma, N minus 1. Okay. Then we need to have the one possibility in which we need to move. So we need to move in the direction. Let's say that I want to move in the right direction. So we need to write recursive function for it. So let's say that next we need to move it in the down direction. Then we need to write recursive function for it. Then we need to return the final recursive call. So these are the few things that we need to look into. So let's start our right thing. So if we need to move right, how we can move right? We can move right by adding, by keeping the row same, and by increasing the column by one count. So we have moved right. How we can move down? We can move down using solve. We can move down using recursive calling that function by increasing the row count followed by call. How we can, what is our recursive call? We need to sum the right plus down. So what is this base case number 2? If our index, which is row, reaches m minus 1 and if our column reaches n minus 1, what we should return? The valid path. Okay. If our row is going outside m or if our column is going outside n, we should return invalid path, which is 0. So technically m is the, if it is going, let's keep it as, let's keep that recursive call as equal to also, because this count is length. So 3, if our index reach 3, it will be out of the index for our matrix. So technically we should use equal to also. If it is greater than equal to m, we should treat it as the invalid path. We should treat it as the invalid path. So this solves our problem. Let's try to print the solution. Let's try to run this. So we get 6 in answer. Okay. So let's try to paste our solution in the chat GPT. Let's try to paste our solution in chat GPT. So I pasted our solution in chat GPT and try to submit it. So it is saying that the recursion solution is correct. Output is 6. Now we move to the next interview step. Why do we need dynamic programming? That is now our main consideration. So we see that why the dynamic programming is reached. The answer these two questions would get us more idea. So we see that this is our main problem, and when we try to divide our problem into multiple sub problems, we are solving the sub problems multiple times. We are solving the sub problems multiple times, whether it is 1/1 or whether it is we are visiting the cell multiple times. So technically the solution to that problem is always gonna the same. So technically the solution would be always gonna same. So what we are going to do, we try to create a index of the DP and try to save those values. So the what problem do you see with calculating multiple times? So the problem which we see is we need to solve same subproblem of recursion multiple times. So when we try to solve the same problem multiple times, it will take more time. So our time complexity will definitely gonna increase if we try to visit the same problem again and again. So the next question is, how can memoization help us avoid this repeated calculation? So memoization help us avoid this by repeating calculation. So we will remember our already solved sub problems. So this is the memoization. Memoization. It is the term which is used to memorize something, which is memoization. So we submit this thing. So now the question it is correct, but it is always the same. Instead of recalculating it, we store its result. So we need to define the DP state now. Before writing the memoization code, tell me what should be the DP represent. So we know that DP, it is a matrix which stores the state from row comma call to the m-1 and n-1. So let's copy this thing. So it will be storing valid path count from the row to the source to the destination. Now we try to memoization this problem. So we need to create a matrix and we try to create a initial matrix and we then try to recursively update the or memorize this thing so our memo gets created, so we memorize this thing or we remember this thing. So now the question is, how would you modify this part so that if is already calculated, you need to return it, otherwise in the DP. So let's try to write the complete memoization solution yourself. So we open our VS Code once again. We try to create our DP array. How we can create our DP array? We can create our DP array by multiplying the column for in range m is the rows. We have this much rows. So this is our DP array. So if I say that if I already have calculated this particular index, so if our index value, if we are on the particular index, so let's say that if our index is if our index which we are on is a particular memoized value, if it is something like -1 already, we can remember it. Okay, so how we can remember it? We need to first calculate our DP, update our DP. Let's update our DP row from a column with right plus down. This right plus down would be replaced by here, and if this value is already calculated, which means that not equal to -1, we should return this value. Okay, so what we are returning now, we are just memorizing the solution according to the memoization concept. We try to memorize that, we calculate that post so there is a term, we need to identify where our recursion is going on. This is the place our recursion is going on. Before it, we will try to see if our value is existing or not. After that, if it is not, we try to update our recursive function. Okay, so this updates our setup. We try to run this program, we again get the same answer. So let's try to copy this solution of memoization and paste it in the chat and try to get the solution out of it. So it says that your memoized solution is complete. So we provided the solution to the ChatGPT of memoized solution. Memoized solutions. So what we are seeing here is that we have calculated once, and we have complexity according to the complexity. This is our recurrence relation. Now the question number 9 is find the dependency. Your memoization recurrence is this one. So to calculate dp row comma column, which two dp cells must already be calculated? Which two dp cells must be already be calculated? Give me their indices only. So technically we should know if we are on a row comma call as our current index, as our current index, our right is on the same row, just we have column increment. Then we have a down, we have a row increment followed by a call, the same column. So these are the two indices which we are looking for. These are the two indices. So exactly, if we are on this cell, our rightmost and the downmost is only that we need to know, and apart from that, nothing else we require. So this is our assumption. Okay. So now the question number 10 says that we need to find out the traversal direction. So if our DP needs row comma col, cell on the right and cell below, what approach should we follow? So for example, if we are traversing from top to bottom, do we able to know our next cell? I don't think so, because we need to create the DP array from bottom to top. Then only we would be able to do that. So answer would be bottom to top. Always when we need to go to the next, or you can say that if it is in the down direction, we always follow the opposite path in the traversal approach. And we need to find out the right thing. So we need to traverse or fill the array from right to left. So we will be following these two approaches. So now the question here is, before calculating the cell, the current cell what which we are going to traverse. Now the question number 10 says that base case in tabulation format. So our recursive base case was, this is our recursive base case was. How would you represent the same base case in the DP table? Write only the initialization statement. Okay. So it is asking if you are on the last cell, if we are on starting from the last cell, how we can, what should be our base case? So technically, if you are already on the last cell, that is your already valid path. Okay, so if you are already on the last cell, a dp of m minus 1 and column and n minus 1, it means that you are already on the last cell. If we are already on the last cell, we don't need to go to any other cell. So technically, that is already my valid path. We should go with row comma column. We should for our base case in tabulation format or recursive, we need to know what is our this cell. Then we calculate the values for the next cell while we traverse. Then with the next cell accordingly. So we need to know now what is our. So if we are sitting on this cell, there is no down, there is no right. We are already on the destination. If we are sitting on this cell, then there is one valid path to go to right. Okay, so that is our understanding. So if we need to initialize our initial statement of the database of the dynamic DP array, what we should initialize with? We should initialize with our the base case. If it is the base case, we should start with if we are on the row, the last one. Let's say that if we are on the last row with the last column, that is my valid path. So that is my one of the assumption. Okay, that is my initialization. Okay, so it says that if we initialize with this thing, this is exactly the tabulation that we are expecting to do. So let's move forward. Now we know the three things. We know that this is my base case, this is my dependency, and this is my traversal. We would be traversing from bottom and going till up. Now it is asking try to write the complete tabulation solution yourself. Remember that when we move from this and that direction should contribute to 0. So this is my ask. Let's open the VS Code and try to see if we are able to visualize it properly or not. Till this point, this is our recursive solution. This is our recursive solution. We are trying with now approach of tabulation solution in which we are going to represent use the same data DP array. So we move the row from the last row. So last row is m minus 1. We need to move minus 1 step. Then we need to move column from the last column till the available column. Then we need to initialize our base case. We need to initialize our base case, which is dp of m minus 1, n minus 1 is 1. Once we initialize our base case, once we initialize our base case, what we need to do? Let's come back to our browser. So we have initialized our base case. Now we need to match our dependencies and we need to traverse through the loop. So let's try to match our dependencies. We open our VS Code once again. So our right is dependent upon the row and the column. Right is dp of row and column. Our down is dp of row plus 1 and the column. Finally, our dp of row comma column is right plus down. But this will not work. So suppose we say that we are on the last cell. If we are on the last cell, then what would be that? Let's say that if we are on the last row itself, there is no down we can go. Okay. So if we take about our question, if our column is, if our, what I mean to say here is we need to check this thing. Okay. If we need to move down, it means that we are moving the row one row down. If we are moving one row down, it means that we need to check this thing. If it is non-existing, if row plus 1 is greater than equal to what row represent m minus 1, then what we should do? If the row plus 1, if we calculate the row and its value is come out the m minus 1, then we need to update this value, else let's make our down as 0 only, that is the invalid path. But this is not correct. We can see that if it is greater, technically it will fail. So what we need to do, if it is less than equal to m minus 1, then we, if it is equal to m minus 1 also, then that is also fine. And we can update our solution accordingly. Similarly goes for the right also. Let's make our right path as invalid, and if our this is going out of index, this is going out of index. Index here is represented by n minus 1. Then we can update our right also, else the right would be invalid path. Then we can sum these two values. Okay. I hope this thing is, let's comment this section for now, and we try to print our dp array. It is saying 6 on the 0th index, which I hope it is to be correct. So we need to get the 0th index. That is our solution. Let's try to paste it in the chat GPT and submit this solution. So it says that very close or something is there. Your traversal and dependency handling are correct, but there is one important bug. You correctly set this thing, but immediately afterward in the same iteration you calculate the down. When the row column is the destination, right equals to 0 and down equal to 0, that is so override the one you just assigned. So you need to stop processing the destination. Okay, it is asking us to stop processing the destination if we are already on the destination. That is correct actually, because if we are processing the destination once again, it will not suffice our purpose. So what we should go back to our VS Code. We see that this is, though this is our base case, we should not process this thing, our base case. If our row is m minus 1 and our column is n minus 1, then we should update the base case and then we should continue this loop, because the last base case should never be overwritten. Then we run this solution once again, though it will not cause any change in the result because of our index is designed like that, but this is a bug. So it says that now our solution is correct. The continue is important because it prevents the destination from being overwritten. That is the correct thing. If we see our browser now, it says that your tabulation solution is now correct and it prints correctly the output. So one minor improvement for tabulation, you can initialize with 0 instead of -1, because uncomputed invalid directions naturally contribute to 0 in this counting problem. Yeah, that is fair enough. We can do that too. So we can initialize our DP array with 0. Now the question comes here is how we can optimize the space. So we look at our dependencies. So our dependencies is these two things. Suppose we currently calculating current row. Think carefully, where does the down value comes from and where does the right value comes from. Based on that, how many 1D arrays do you think we need? Okay, it is correctly asking you if you need to move down. If you are on the current cell, either you would require the down row plus 1. If you are on the current cell, if you need to move to right, you would require column plus 1. So down value comes from the below row, the right value comes from the next column. Based on that, how many 1D, one-dimensional arrays do you think we need? So we can say that we need next row and current row only. Now it is asking us to now map the old 2D recurrence to these two arrays. We need to think carefully how we can do that. Is on already calculated row below, so it becomes the next row. Okay, so if I need to convert my code, let's open our VS Code. This is our updation for the right. If I say that This is my GP row. I can represent it with, let me comment and write it down like this. Right equals to current row with a column plus 1. Similarly, for down, it would be next row with the same column. So I can clearly see that that will suffice my purpose. Let's copy this and paste it on, in our Chrome. Yeah, it is next. I just write it next. It is next row. So this mapping is the key to space optimization. So we don't need complete 2D array. We can have a small 1D array as well. That will suffice our purpose. So question number 15 is asking, before processing any rows, we need the next row. Since our destination is at m minus 1 n minus 1 and represent one valid path, how would you initialize next row? So that is correctly represent the last row paths count. For m equals to 3, n equals to 3, think about what the entire last row should contain. What should these three values be? What should it contain? So if you are on the very last index, if you are on this index, if you are on this index, if you are on this index, that is already on the destination. That is neither we are moving down or neither moving right. So we are already on the destination. We don't need to. If we are on this index, this is our one valid path. If we are on this index, we are having this valid path. So can we initialize it with 0 and later on start filling with this thing? So now it is asking, then traverse from the last row right to left. We are at the destination. What assignment should we make for the destination? So for the destination, if we are already on the destination, we can assign it with 1. For Write the loop that fills the remaining last row cells right to the left starting from n minus 2. Okay, so it is asking us if this is our next row initialization, and if our next row initialization of the last cell is 1, how we can initialize our what is this range? We need to traverse from right to left. So if I copy it like this, so if I need to traverse from right to left in range, I need to traverse from right to left. Let's say that from n minus 2, minus 1 and minus 1. So we have filled our last row. This is our last row looks like. Now the next question is process the remaining rows. We need to start processing the remaining rows. So we need to continue it from here. So we have our next row. Let's copy this part. We come back to our VS Code. Let's comment this complete section. So we need to continue from here. Okay. So we need to have a movement for row and columns. Let's copy this here. So our next row is already in place. We can start it from m minus 2, from n minus 1 till we go up. There is no DP such thing. We would be avoiding the DP. So for every row, we will be creating a current row index. So this is my row. For every row, I would be creating a current row index. So this base case would never be existing. Why? Because we have already taken care in the next row. We can remove this portion. So this is our current row. This would be replaced by current row. This would be replaced by next row. This is our current row. Then our next row is equal to current row. We can get the solution from this. Try to run this solution. We get the answer. Let's try to paste this solution in the chat GPT. So it says that the solution is correct. Let's see if any bug is there. So it is suggesting you final optimized recurrence becomes like this. So down we would not face any issue because next row is already calculated as per this instruction. We can relatively yes see this section as a removal. We can directly update it. We run this code again, it will work. So this is our final solution. So we have completed the unique paths through all the four stages: recursion followed by memoization, tabulation, and space optimization. So memo is one of the most important things from where the actually the optimization starts. And the key idea to carry forward is space optimization comes from asking which previous and future DP states the current state actually depends on. Yeah, that is the correct understanding. Now let's for the question number two. Okay. So before moving to the question number two, let's take some break and we will see